So welcome back. In the last topic, we were discussing about the types of metals. Then we have discussed about the further classification of metals is about the ferrous metals and non-ferrous metals. Then we have discussed about the what is ferrous metals. So ferrous metals is nothing but an which contains the iron content. Where in the non-ferrous metals, it does not contain a iron content like aluminum or brass or copper. So these are some of the examples of non-ferrous metals. Next we are going to discuss about the what are the different types of ferrous metals along with the what is the percentage of metals that contains in the ferrous metals. First we are going to discuss about the pig iron. So it is an intermediate product of smelting iron ore with a high carbon fuel such as coke, usually with a limestone as a flux. So it is a molten iron from the blast furnace. So furnace, what do you mean by, before discussing about these types of metals, we should know about the furnace. Furnace is nothing but the where we are going to melt that iron metals into the form of liquid. So we are going to pour that liquid into the which are the shapes made for manufacture of that particular product. What are the type of the shape should be there for that particular product, we will be design that particular type of shape on that product. Then we are going to pour that molten metal where we have burnt from the furnace. So that is furnace is nothing but where we are going to use or we are going to melt that materials and we are going to pour convert that molten metal, that is molten metal will be in the form of liquid. We are going to pour that liquid to the product shape which is the shape already we have been designed. We are going to pour that molten material on that shape. So automatically the product will be there, what is the shape we have been designed. So pig iron is nothing but it is a type of one of the iron where it is been used in the iron ore, where it will be having an high carbon such as coke, and usually we mix with the limestone as it is a flex. It is the molten iron from the blast furnace. So next one is about the wrought iron. So these also the different types of iron. For example, if you take in a cast iron, I will consider in that again it comes the different types of irons. Mainly it is used for the different applications where we are going to use this, like if you consider a pig iron, wrought iron, cast iron. So cast iron is a wrought iron is an iron alloy with a very low carbon. See here in this wrought iron the carbon content is very less, so it is less than the 0.08% of that particular content, so which is contrast to the cast iron, and as in a less fibrous inclusions known as slag. Slag is nothing but the where it is the small dust particles will be formed on the molten metal. So it is used to remove the, means that is the dust content that will be what we generated from whenever we are going to burn the material, that is what we called as a slag. So next coming to the cast iron. So the cast iron is an alloy of iron, means it's a mixture of both the irons where it contains a 2 to 5% carbon, 1 to 3% silicon, and traces of magnesium, sulfur, and phosphorus. So next type of iron is about the grey iron, or we call it as a grey cast iron. It is a type of a cast iron. So cast iron is one of the strongest material in compression but weak in the tension. So wherever we are going to use a cast, it is one of the strongest iron content material with as a graphite microstructure, and it is named after the because of the grey color. The color is there. So based on that they were named as a grey cast iron. So it forms with the due to the presence of the graphite. It is the most common cast iron and most widely used for a cast material based on the weight. So what is the major advantage of this grey cast iron is it is most widely used cast material based on the weight, means to withstand the more weight of any product or any component. So we are going to use this material in order to withstand that more weight on that particular product. So major things of this cast irons is about the applications is automotive engine blocks or a gears, because it has to withstand the more pressure and more loading, and flywheels and frames. So these are the materials that has been manufactured based on using these materials. Next we will go to discuss about the white cast iron. So the white cast iron displays about the white fractured surface due to the presence of cementite. Why the form or the color comes in the form of white is because of the presence of cementite content with a lower silicon content and faster cooling rate. The carbon in the white cast iron precipitates out the melt of the metastable phase, so rather than the graphite. And the composition of this white cast iron is 1.8 to 3.6% of carbon content will be there, and 0.5 to 2.2% of silicon content will be there, along with some small content of sulfur. So the major application of this white cast iron is car wheels. So where we can able to see the wheels which has been manufactured by using this white cast iron, and the sprockets inside the engines, and the rolling mills in the rolls where we are going to use this. So next type of other types of irons are malleable iron. So it is a casting that heated about the 9900 degrees Celsius. So when you are going to heat this malleable iron after the 900 degrees Celsius, so the graphite separates out much more slowly in case of, so the tension has no time to form in the spherical particles rather than the flakes. So in this, after heating, what happens? So the flakes start forming after heating at a 9900 degrees Celsius. So the composition of this malleable iron is 2 to 3% of carbon content will be there, and 0.6 to 1.3% of silicon, along with small content of sulfur. So the major application of this malleable iron is universal joints, yokes, differential gears, compressors, and crankshafts and flanges. So all these components are mainly used in the engines in order to run the engine properly. Without these parts, so the engine cannot able to run. So next one is about the mild steel. So the composition of the mild steel is, so alloy of iron is 0.15 to 0.3%. Carbon will be there, and properties and characteristics, it's in the tough, ductile and malleable in nature, and good tensile strength, poor resistance to corrosion. So the mild steel is the poor resistance to corrosion, means easily it attacks the corrosion. So the major applications of a mild steel is about the general purpose of all the engineering materials where we are going to use normally in all the engineering materials. So next one is about the steel. Steel is an alloy of iron and carbon widely used for construction. See, we can see that steels. So in the construction mainly it is used as a steel. So these are the some of the major types of iron contents in the, or different types of iron materials in the ferrous materials. So next we are going to discuss about the types of non-ferrous materials. What are the different types of non-ferrous? Similarly, we have discussed about the different types of ferrous materials like pig iron, wrought iron, malleable iron, grey cast iron, white iron, and steel. So these are the some of the materials widely used in the engineering applications in ferrous materials. Now we are going to discuss about the different types of non-ferrous metals. So the majorly the first comes is about the aluminium. So aluminium is a chemical element in the boron group with a symbol what we called as an AI is a symbol for aluminium, and the atomic number is 13. It is silverly white, soft, and non-magnetic, and its in a condition is in a ductile material. Aluminium is the third most abundant element after the oxygen and silicon, and the most abundant element on the earth's crust. It makes up to 8% by weightage of the earth in the solid surface. So it is one of the most third most abundant element on the earth's crust after the oxygen and silicon, and it is a symbol is represents the AI, that is the aluminium is indicates AI, and the atomic number is 13. So the composition of aluminum is the pure element, or a pure element what we call it as an element. So the properties of aluminum is about the good characteristics, good strength to weight ratio, light, soft and ductile, and good conductor of heat, and that is a good conductor of temperature, or we call it heat and electricity. So the major applications of aluminum is about the kitchen equipments, windows frames, general cast components, and mainly this aluminum has been used in the for the seating purpose in the aircraft industries. So what is the why we are going to use aluminum is it is weight strength is more comparing with the other elements, and the weight is very less. So that is one of the major reasons. Still, whenever we are going to use the composite materials in the aerospace industries, but still we are going to use it seating for all the seating purpose. So the aluminum is only preferred in order to for the seating purpose in the aircraft industries. So these about are the classifications of non-ferrous metals. So next we are going to discuss about the composite materials. What do you mean by a composite materials? So the composite material is a mixture or a combination of two or more materials in a macroscopic level. So by mixing or by combining two or more materials together, it will form one different material. So that type of materials what we call it as a composite materials. So the composite materials is will be mixed in the form of macroscopic level and they are not soluble in each other with one of the materials. So that what we call that process what we call is reinforcing phase. Means whenever we are mixing two or more materials, it will be not soluble with the other material. So how we going to mix, or how we going